I love PHPStan. I think it is an incredible tool. It is one of the best things, I think, that has happened to the PHP ecosystem. And if you use it on your projects, you'll have high quality code and you'll have fewer bugs, you'll have fewer defects. And if you create your own custom rules, they amplify the benefits of using tools like PHPStan. And I'm going to give you we're going to create together three custom PHPStan rules during this talk, and they're going to solve three different problems, just so I can show you the power of what we can do, and hopefully you'll be able to take this back to projects you're working on Monday and apply something similar to what you're working on. There is, I think, a bit of a precondition for this talk. Ideally, you've got to know what PHPStan is and static analysis. So if you've never heard of PHPStan or you don't know what it does, this might not be the one for you. By the end, I'll have shown you how to create some custom rules. But just one more warning. There's a lot of code in this talk. It's quite a technical talk. It's probably the most advanced one that I do. So if any of that puts you off, now is a good time to pop next door. You've all stayed. Fantastic. Right. This is our kind of agenda for today. We're going to look, first of all, how we can use custom rules to document coding standards and enforce them automatically. Then we're going to look at some other PHPStan rules to help with upgrades and to eliminate bugs. So how do you document your coding standards at the moment? For a long time, I was on a project. I was working with one other person, and we had it all in our head. We just knew what the coding standards were. You know, we kind of chatted away, and it was just in our heads. And then eventually, we got new team members come along, and they didn't know what the coding standards were because we hadn't written them down. So we wrote them down in a markdown document in the GitHub repository. And of course, they kind of read it. They sometimes forgot. And there was a lot of time we had to keep going back and back around in code review to say, look, you haven't followed the coding standards. So in the end, we automated them using PHPStan. And now, when they finish working on their code, they just run PHPStan, and it will tell them of any coding standard violations, and they just fix it there and then. So that feedback loop is much quicker. And we're software developers. We want to automate as much as we can. So generally, the further along you are the line to automation, the better it will go for your project, especially as your team increases in size. So I think when it comes to coding standards, there's kind of two categories. There's things like, this is where our opening and closing braces are going to go. This is how we order our use statements, and so on and so forth. So there's kind of formatting and style. And then there's rules that I think require a much deeper analysis of the code base. So the formatting ones, we've already got tools that can do this. You're probably using CSFixer or Code Sniffer to check your code and in some cases automatically fix any issues that it finds. But for the ones that require a bit of deeper understanding about the code base, we can use PHPStan and create some custom rules to enforce those particular coding standards. So I'm going to take an example from the SPARC coding standards. They say that your URLs have to be kebab case, and any of the parameters within the URL needs to be camel case. So we're going to create a rule now that enforces this and checks that this is the case. So here's some examples. We've got the first three. These are all correct. And then we've got a couple that are wrong, and I've highlighted in red why they're wrong. So we're going to make a rule that checks this. Now, the actual logic of checking whether the URL is correct or not, I mean, that's just a bit of regex. So I'm not going to worry about that. That's not the interesting bit. The interesting bit is how we tell PHPStan to look out for calls to root and get and post and put, and then check whether the string we passed in is of correct format. And if you're in Symfony world, you probably use the root attribute, and you could do a similar kind of rule to this, but you'd be looking for the root attribute rather than the method call. But before we create this rule, I've just got to explain something called the AST, the abstract syntax tree. So when we write code, or the code we've written to getting executed goes through many steps. The first step is it goes through a tokenizer phase, and this is where I think tools like Code Sniffer and CS Fixer, they look at the tokenizers, the tokens to work out if there are any coding violations. The next step, it gets converted into an abstract syntax tree, which we're going to talk more about. And then that gets converted into opcodes, and the opcodes are run on the PHP virtual machine. But the bits that we are interested in is the abstract syntax tree from a static analysis point of view. So all PHP code that we write can be modeled in the abstract syntax tree. It's just a tree representation of our code base. So if we take this code here, the first thing we've got is a class, and there is a node in the AST called the class, it was a type class. And that has properties, and then we might have a name property, and in this case, person notifier is an identifier type of node, and that has a property name, which in this case is person notifier. Also, a class can have 0 to infinite number of statements, and the statements in this case, we've got a property declaration and 2 methods. So if we delve a bit further down, if we've got this notify player method, we've got a function, or a method call, so there's a method node, and then that also has a name, it has some parameters, and again, it has 0 or infinite number of statements. So the key thing is, all of our code can be represented in an abstract syntax tree. And there is this library made by Nikita called the PHP parser library, and that has PHP representations of every node that appears in the abstract syntax tree. So the key thing that I really want you to take away from this section is all PHP code can be represented in the AST. There's lots of different types of nodes, depending on what code it is representing, and each type of node contains different types of information, depending on what is representing in the code base. And if you haven't got that first time round, don't worry, because we're going to go through it a few more times when we actually use some real examples here. So now we're going to create our first rule, and we just need to understand a bit about how PHPStan works. So what PHPStan does is it goes through the entire abstract syntax tree, and it says things like, I have got a class node. Any rules interested in a class node? And some of the rules say, yep, I'm interested. And then PHPStan will pass over to the rule here saying, this is this node, do your analysis, and let me know if there are any problems you find. And either it'll find an issue or multiple issues, or it'll say, no, I'm happy with that. And eventually it goes through the entire abstract syntax tree, and all the rules that are interested have all put in their problems that they found, and then it reports it back to you, the user. And all rules, whether they are PHPStan rules or the custom ones we are going to create, they all implement this interface. And there are 2 methods we need to provide an implementation of. The first is getNodeType, and that is to say what node in the abstract syntax tree this rule is interested in. And then we have a processNode method, and that takes a node, it takes some additional information that PHPStan provides through scope, and then it returns an array. If it hasn't found any issues, it returns an empty array. Otherwise, it returns an array of any number of issues that it finds. So a rule could find more than one issue if it wanted to. So the first question we're going to ask, what node type are we interested in? So the code that we want to find a bit more information about, or the code we're interested in, looks like this. It's root, : get, and then we're passing something to that call. And once you've done this a while, you kind of know what most of the nodes are, or node types of nodes are in the abstract syntax tree. But when you're starting out, you probably want to use something like an online AST viewer. So this is one of them. That there were quite a few. And what you've got on the left, you've got your PHP code, and on the right is the AST representation of it. So if we looked at that, we'd actually see this code is a static call. So there's a node type called static call, and it has what we're calling it on, the class. It's got the name, in this case the class in this case is root, the name is get, and then we have a number of arguments. And if we looked at the Nikita's PHP parser library, and we will find in there something called static call, and we can see on all of these kind of things, they have some properties at the top, and that's normally what you're interested in. So we can see it's got a property called class, and we can see how that kind of relates to the root here. We've got a property called name, and in this case it's get, and then we've got arguments. Okay, so we've got our code, it's modeled in an abstract syntax tree, and then we have a PHP representation of that particular node that's written in PHP. So coming back to the rule that we want to create, I shall call this a root rule, probably is a better name to be honest, and the node type we're interested in is a static call. So this rule will only be passed nodes that are static call nodes and nothing else. So the process method, we've got the node, in this case we know there'll only be static calls, we've got the scope, which we'll talk about later, and then we're going to return an array. So we're going to ask 3 questions. The first question is the thing we're acting on root? So what we first of all do, this might look a bit odd, we're saying if the node class is not an instance of name, then we're going to exit with an empty array. So that means it hasn't found anything. And you might be saying, why would you do that? Well, if we go back to the static call, we can see that $class can be of type node or an expression. Sorry, it can be of type name or an expression. So this is what name would look like. And if you wanted to, you could make an expression. So this rule isn't going to be clever enough to work this out. So if you had $class name equals root, and then you call this, it's not going to find that because we're just going to stick to this simple thing here. So we're saying if I'm not an instance of node, then return an empty array. That means I'm not reporting any issues. Otherwise, we know that it is an instance of node. So the next question we're saying, is it an instance of root? And if it isn't, we'll exit because we're not interested in that. We're only interested in calls, static calls on the root class. Kind of makes sense? Yeah? Yeah. The second thing we're interested in is this a method that we need to then look in more detail on? So again, we've got this thing, I'm only interested in identifiers. And again, if we look at what $name can be, it can be an identifier or an expression. So we're just going to keep it simple for this rule. So we're saying if it's not an identifier, then exit early. Otherwise, is the method one of get, post, put, and delete? And if it isn't, then we'll exit. And if it is, then we get on to stage 3. So stage 3, we're saying, what is the argument? What's the first argument? Is it a string? And then if it is a string, we can do some analysis on it to find out if this is a correct URL or not. So again, like before, well, actually, we're saying, is there an argument? And if there isn't, we'll exit. And if there is, we're saying, is it of type string? Because maybe we're passing something else in. And if it is of type string, then we can get the value from the string here. And this is my root validator validate. That does all the regex to say whether this is a valid root or not. So what's happening in stage 3 is we're saying, have we passed a string as the first argument? And if we have passed it, is it a valid URL? Does that string represent a valid URL? And if it does, we exit. And if it doesn't, that means we must have an error. So we've got a call on root, which is the method we're interested in. The URL, the string passed in, is not a valid URL, so we need to report that back to the user. So we've got a message, URL must be kebab case and parameters in camel case, and then we return, in this case, just a single error. We use PHPStan's rule error builder just to make it easy to create the error. We put in a message, put an identifier, we call build, and this means that the user, when they finish running PHPStan, will have been reported that there's been a call to root and it's not a valid URL. Okay? So if we've just done that, it's not a huge amount of code, and we have implemented something that is in our coding standards. It becomes part of our project, and every time somebody runs PHPStan, it will tell us if we've made a mistake. And it's not a huge amount of code. We've done that in maybe 5-10 minutes. So I think these things are really, really quite powerful for that. There is a little bit of admin, though. Where are we going to put these rules? Well, if they're on my project, they're specific to my project, then normally I create a build folder at the same level as source and test. I might be using other rules, so I have a PHPStan one in there, and then I have a rules section, and that's where I put my rule. We also have to tell Composer where to find these rules, so we, for the autoloader anyway, so we add that. And then finally, we need to tell PHPStan about this rule as well. So this bottom bit here would live in the phpstan.neon file, and it's just saying, by the way, PHPStan, here's a rule that you also need to consider when you're doing your analysis. And if you want to see an example of that, I'll share the slides, but there is a GitHub repo where all the code is there. So what we've done is we've looked at an item in a coding standard, and we've created a rule. And we could probably go through this. You've probably all got coding standards, or perhaps you all should have coding standards, and you could probably spend a day or two going through it, creating rules, and suddenly they're all enforced automatically. I think that's really powerful. So that's I think, pretty cool. There is another example of things we could do. We could create PHPStan rules to help with upgrades. So imagine I'm now putting on my library creator hat, and let's say I've written a library. And I know I'm going to go from version 1 to version 2, and as part of that update, I'm going to change the alert service to also take a type. And actually, this is something that PHPStan did when it went from version 1 to version 2, was add in an identifier. So it's a similar idea to what PHPStan did. So my version 1, the alert method just has just got a single parameter, which is message. And in version 2, it has two parameters, the original message one and the type. Now, what we could do is we could release an intermediate release, and this is actually what Symfony does. So let's say version 1.1 is the last minor version of 1. And what we can do is we can modify the alert service in such a way that it's compatible with the version 1 version and also the version 2 version. So what we're going to do is we're adding in our extra parameter. We'll call it type, we'll make it nullable, and we'll give it a default value of null. That means that's not a backward, you don't have to change any of your version 1 code for it to work with version 1.1. And when we go to 2, we'll just make it more strict so that $type has to be provided and it can't be null and there's no default value. But this provides us a stepping stone. And if we created that, what probably would happen inside the alert method is we could trigger a deprecation warning if type was null. So this is a runtime way of doing things to warn people that they're going to have to make a change ready for version 2. And that's kind of all right, but you need to actually run the code to find all the places you've used it. So if you've got a good test suite, you could run your test suite, you could look at the logs and then go through each of the deprecation warnings. Or if you put this on a server, you could look at all the deprecation warnings that comes up. But it does rely on this code being called. So I think in this case, static analysis is a better way of doing this. So if we think about it, we are looking for some code that maybe looks a bit like this, where this section refers to an alert service. We've got two arguments. The second one is either missing or a null value. So we need to create a rule that looks for code that looks like this, and then we can tell developers that you can't upgrade to version 2 until all of these have been found and rectified. So if we want to create a rule that looks a bit like this, what we can do is the code we're looking at here, this is called a method call. Again, you could put it into the AST Explorer and it would help you find this, but this type of node is a method call. It's got a var property, which is what you're calling the method on. It's got a name property, which is the name of the method you're calling, and it's got arguments that you're passing to this method call. And again, if we were to look in the PHP parser library, we can see that there is something called method call, and we can see it's got 3 properties. It's got the $var, $name, and $args. So we're going to create a rule to find the bits in our code base that we need to change so we can do an upgrade. I'm going to call the rule alert service alert upgrade rule. I'm clearly not great at making names, but you know, I suppose it sort of says what it does. And the node type that we're interested in is a method call. Hope that's all okay. And now the next step is we need to create an implementation for process node. So again, we're going to ask ourselves 3 things. The first thing we're going to ask is the call on an alert service object? So remember, we're looking for code like this, and we're asking, is this bit here, the bit in blue, does it refer to the alert service class? And this is one way we can do it. Object type is PHPStan's representation of an object. We can't instantiate the alert service in the PHPStan rule, but we say, I'm interested in an object of type alert service. And then scope is provided by PHPStan, and it gives us additional type information about the particular node in the context that node is in the code base. So here we're asking, saying, get me the type of node var. And then we've got this if statement, and what this is essentially saying is, if we're not acting on alert service, then return an empty array. So if it gets beyond here, PHPStan has decided that $node var is an alert service object. So if we're acting on an alert service, the next question we need to ask is the method we're calling on the alert service the alert method. So we can go and get the name, and again, it's just like with the previous example, we're only interested in identifiers. We're not going to do anything clever with the expressions. And then we say, if the name isn't alert, then we'll exit. So if we've got below this if statement, we know we're acting on an alert service object, and we know the method we've called is alert. So the final bit is, what are we passing to it? So the first question we're asking, have we passed at least 2 arguments? If we have, is the second argument a string? Which we're asking, first of all, is it of type arg? And then this bit of code is saying, is the second argument definitely a string? So if it's not a string, or if it's string or null, this won't go into the true branch. So what this bit code here, we get to this return thing only if we've got at least 2 arguments and the second argument is a string. So we'll exit if that's the case, otherwise we'll fall through the loop, and then we'll get to this bit here where I said, if we've got this far, we've got a problem. We are either not supplying the type arguments, or it's not a string, or it's not definitely a string. So again, we just create an instance of a rule using the rule builder. Sorry, we create an instance of an error using the rule error builder, and this will report any problems that there are that will prevent us from going safely from version 1.1 to 2. And if you've got a library, you've probably got many things you want to do in the library. Maybe you're going to mark classes that are deprecated, methods, parameters that are going to be removed. We can create rules for all of those, and we can package those up. So once I've created all these rules, how do I share, if I'm wearing my library maintainer hat on, how do I share these rules with other people? One way you can do this is we just leave the library code intact, and then we create a second package, which is kind of my library v1 to v2 upgrade rules. And the second package will just have all the rules that we have to safely go from version 1.1 in this case to version 2. And there's a few things about the composer.json file for this library. The first thing, we'd have a name. It's pretty standard, but the type, we would say it's actually a PHPStan extension. So that means if people are searching for PHPStan extensions in Packagist, they're much easier to find because you can search on types in Packagist. We would require, amongst other things, we would require, specifically in this example, 1.1 version of the library, because this won't be valid before version 1.1 because we won't have added in the extra field, and it won't be valid once you go to version 2 because everything should have been upgraded. And then you also put in this extra section to tell PHPStan this is an extension, and this is where you can find the file that tells you where all the rules are. The common convention is to call this extension.neon. It doesn't have to be. But whatever we call it, extension.neon, we then need a file with that name. So in this case, extension.neon. And this is just telling where the rule is. So this means that if you are on a project and you're pulling in an external PHPStan library, how it knows where to find the rules that are in that external PHPStan library. So that's me with my library maintainer hat on. So I've done all this rule, and now I'm coming to step here as someone who's consuming that library. Well, what can I do? How can I take advantage of this package of rules? Well, one thing I could do is I could just add it in to the main PHPStan analysis check, and that would be fine if it's quite quick to go and fix them all. But if this is a big code base and there are many, many things that we need to fix, then maybe what I'll do is I'll just create a standalone PHPStan config file that focuses just on this upgrade. So maybe we've got a huge project that makes many, many, many calls to this library that's being upgraded. And if we split out our PHPStan config files, it means one person or one team can be responsible for doing all the work to do the upgrades, and the others can just get on with their code without worrying about these new issues that would be coming along. So we can just create our own PHPStan neon file. We just have to say custom rule set used true, so it doesn't go and do all the normal PHPStan rules. We say what the path we're interested in, and then we link to the extension that we've just created. And we can run this separately by just using the -c and then the name of the config file. So this is quite a neat way of separating out the tasks from doing the upgrade just to doing run-of-the-mill normal development. And you'd only do that if the project was big enough. So there's one final example I'd like to share with you, and it came about because of a mistake I made. So I've created something called the PHP language extensions library, which is a whole series of attributes which you can put on your code to emulate features from other languages. And they are enforced by static analysis, and there are a whole number of rules. And you have to reference the rules in the extension.neon file, because otherwise projects that make use of these rules, make use of this package, don't know where all the rules were. And I once released a version of this where I'd forgotten to add the new rule into the extension.neon file. So I thought, how can I get around this? Well, I could, of course, write tests, but the problem with writing tests is every time I create a new rule, I have to create a new test. I thought, is there a better way of doing this? I thought, well, actually, I could create a custom Stan PHP rule, and what it would do is it would go through my project, my extension library, and it's looking for code that looks like this. It's looking for anything that implements rule. And then it's saying, anything that implements rule, is that also referenced in the extension.neon file? And if it isn't, I will raise an alert, because clearly that's what I need to do. So I created a rule, check rule is an extension. The thing I'm interested in is a node type called in-class node. And then what I did is for the process node, the first thing I do is I'm actually just going back down to normal class reflection, I'm saying what is the name of the class that I'm in? Then I'm saying, is it a subclass of rule? And if it isn't, I'll exit because we're not interested in that. And then there might be a few other things we don't care about. For example, if it's an abstract class, then we wouldn't expect that to be in the extension.neon file. So we're going to ignore any abstract classes. And then we've got some upcode extension file checker is in file name. So this is saying, is this class name referenced as a rule in the extension.neon file? The implementation of that is not really that interesting. And if it is, we're okay. Otherwise, we fall down to here and we say, Dave, you've forgotten to add your rule to the extension.neon file, so no one will be able to make the benefit of that. And I think this does ask an interesting question of where we should do some kind of analysis. Should we be doing it runtime, like through tests, or is it sometimes better to do static analysis? And there are cases, I think, where static analysis is better than creating tests. I mean, I'm not saying don't write tests, and I had created lots of tests, but there are some things where it's just easier to create a PHPStan rule to make sure things are set up right. And actually, maybe these kind of configuration files are one benefit of using this static analysis approach. But I think the real takeaway from this section is whenever you have a problem, or whenever some bug gets into production, ask yourself, how did it get into production? And how can we prevent that from happening again? And normally what you do is you get a bug, you'd write a test, you see the test fail, then you go and fix the code. But another thing to think about is, could a custom PHPStan static analysis rule have found this issue? And if it is, it's probably worth making it because that will prevent any similar issue from happening. So these are things we've discussed. We've seen how we can use PHPStan to enforce our coding standards. We've seen how it can help make upgrades more pain-free, and we've seen how they can eliminate rules. So this is what I said at the start. I genuinely believe PHPStan is an incredible tool. That's why I've got the t-shirt. It can help us create high quality code with fewer bugs, and custom rules can give us even more power. So that's what we've done. I've been Dave Liddament. Thank you for listening.